what is an electric dipole? An electric dipole is two equal and opposite charges separated by a small distance. And electric potential at a point due to a point charge is the amount of work done to take a unit positive charge from infinity to that point. Today we will see electric potential at a point due to an electric dipole. You have to find out what is the potential here because of the positive charge and what is the potential here because of the negative charge. Then we have to add. So potential at P due to the positive charge is given by this relation 1 by 4 pi epsilon 0 Q by R1 because this distance is R1. From the positive charge, distance of the point is R1. Similarly, potential at P due to the negative charge is Now let us apply cosine formula for this triangle AOP. First we applied for BOP. When we apply cosine formula for this triangle, R2 square is equal to R square plus A square minus 2RA cos 180 minus theta, because angle between this line and this is 180 minus theta. Here it is theta, but this is 180 minus theta. But cos 180 minus theta is minus cos theta. For this, when we put minus cos theta, here already one minus is there, so it will become plus. So R2 square is equal to R square into 1 plus A square by R square plus 2A cos theta by R. Now here R is very much greater than A. So this R is very much greater than A. So this term can be neglected, because when we divide by a very big number, this is going to be very small. So negligible. So this can be neglected. So after neglecting this term, R2 square is equal to R square into 1 plus 2A cos theta by R. After that you take the square root. The square root of R2 square is R2. Square root of R square is R. So when you take the square root of this term, it is raised to half. Now you take the reciprocal. So 1 by R2 is equal to 1 by R. When you take the reciprocal of this term, the power will become negative. So minus half. Now here in this term, this R is very much greater than A. So this term is going to be very small. When it is very small, we can apply binomial approximation. So here 1 plus x all raised to n. When this x is very much smaller, you can write like this, 1 plus nx. So this minus half, when it is taken inside, this plus will become minus, this plus will become minus. Now this 2 and this 2 will get cancelled, so A cos theta by R. So you are getting an expression for 1 by R2. So 1 by R2 is equal to 1 by R into 1 minus A cos theta by R. So already we got for 1 by R1. For 1 by R1, here it was plus. Total potential at P due to the electric dipole is given by this relation. Now by applying cosine formula for this triangle and this triangle, we got an expression for 1 by R1 and 1 by R2. 1 by R1 is 1 by R into 1 plus A by R cos theta, and 1 by R2 is 1 by R into 1 minus A by R cos theta. Now for this 1 by R1, we can substitute this value. 1 by R into 1 plus A by R cos theta, then minus. For this 1 by R2, we can substitute this relation. 1 by R2 we can substitute. 1 by R into 1 minus A by R cos theta. Here we can see 1 by R, again 1 by R. So 1 by R is common, so you take it outside. After taking this outside, here there is 1 plus A cos theta by R, then this 1 by R is taken outside, so minus 1, minus into minus, this plus A cos theta by R. Now this plus 1 and this minus 1 will get cancelled. A cos theta by R plus A cos theta by R, so it will be 2A cos theta by R. So total potential is given by this relation, Q into 2A cos theta divided by 4 pi epsilon 0 R into R. Now Q into 2A, one of the charges multiplied by the distance between the charges, is electric dipole moment. So for this Q into 2A, you can write P. Then cos theta divided by 4 pi epsilon 0. This R into R, it is R square. So total potential at the point P due to the electric dipole is given by this relation. V is equal to P cos theta divided by 4 pi epsilon 0 r square. Potential at the point P due to this electric dipole is given by this relation. V is equal to 1 by 4 pi epsilon 0 P cos theta by r square. P cos theta can be written as P vector dot r cap. P vector dot r cap is P cos theta because modulus of P vector is P, modulus of r cap is 1. Then angle between P vector and r cap is theta. So this can be written as P cos theta. Now we will see some special cases. Suppose the point is on the axial line on the side of positive charge. Theta will be 0. If the point is here, this line will make a theta with this direction. So theta is 0. Cos 0 is 1. So V is equal to 1 by 4 pi epsilon 0 P by r square. If the point is on the axial line on the side of the positive charge, when you try to bring a unit positive charge, this positive will repel. So we have to do work. That is why potential is a positive quantity. Suppose the point is on the side of the negative charge on the axial line. Now this angle will be 180. If the point is on the side of negative charge, theta will become 180. Cos 180 is minus 1. So potential will become minus 1 by 4 pi epsilon 0 P by r square. Now when we try to bring a unit positive charge, this negative charge will attract this charge. So that's why potential is a negative quantity. If the point is on the equatorial line, theta will become 90 degree, cos 90 is 0, so potential will become 0. If the point is on the equatorial line, when you try to bring a unit positive charge along this direction, this positive will repel, this negative will attract. So it will cancel each other, then work done is 0. That is why potential is 0. Now, in the case of point charge, the potential is given by this relation. So here potential is inversely proportional to the distance. But here it is inversely proportional to the square of the distance. In the case of a electric dipole, electric potential will be reduced at a faster rate. The reason it is inversely proportional to the square of the distance. Then in the case of point charge, electric potential is spherically symmetric, but in the case of electric dipole, it is not spherically symmetric, but it is axially symmetric. You rotate this line about this electric dipole moment, so you will get a cone. All the points on this cone at equal distance, potential will be same. Now you consider all the points on this blue lines. So it is at the same distance from this. So potential on this will be same. So it is axially symmetric.